All right. Well, here we go. We're going to learn some proportions. Kind of a special shout out to my friend Sam in Washington who might be watching this and working on some math homework. So here we go. It looks like on this particular assignment, we're looking at proportions and the relationship between taking, for example, 7, a length 7, and a length 4, smaller. There we go. And describing them in terms of either a fraction or a ratio. So sometimes you'll see a ratio and it'll be a ratio written as 7 to 4. It's also written like this, 7 to 4. It also could be written like this, 7 to 4. So lots of different ways to write that ratio. And it looks like what this lesson is going to be about is about building up fractions or kind of tearing fractions down. So creating equivalent fractions that are bigger or smaller than the one you're starting with. So that's what we're gonna go for there. And in this second page, as you kind of look through and see what's happening here with multiplication, I'm just going to do one with a picture first. And I'm going to take our original 7 and our original 4, and I'm just going to multiply each of those lengths 3 times. So I'm going to make this one 3 times bigger, and I'm going to make this one 3 times bigger as well. So what's happened here is your 7 has been multiplied by 3. The dot is used for multiplication as well as an X multiplication sign. So that little dot means multiplication. And your 4 has also been multiplied by 3. Oops, that's not a very good 4. And so as your 7 gets 3 times bigger, it becomes 21, and your 4 becomes 3 times bigger, becomes 12, that is an equivalent fraction. Okay, so anytime you multiply by something like 3 over 3, and we know 3 parts of 3, right? So we know if we take 3/3, we're going to have 1 whole. So it's important to remember when you're working with fractions that if you have a number divided by itself, that is always equal to 1. So that is going to help you with creating equivalent fractions as you move forward. Okay. And then right away, it looks like they're also having you work backwards with equivalent fractions. So let's just take a look at this number 1 here real quick before we move on. So we have 3/4, and if we multiplied that by, let's say, 2 on the top and 2 on the bottom, we multiply fractions straight across in the numerator, straight across in the denominator, and that's going to give us 6/8. So that would be an equivalent fraction. We could even double those again and multiply by 2, or any other number, 3 over 3, 5 over 5, really doesn't matter. And that would give us 12, multiplying across the top, multiplying across the bottom, 12/16. So 12/16, 6/8, and 3/4 are all equivalent fractions. So there you go. So as you continue through this lesson, not only are you finding equivalent fractions and building them up, but you're also breaking them down. So watch out for that as you're looking at problems like perhaps this quick check right here, 21/63. And the way I kind of like to show this at first is maybe you have 21 maybe as a picture. So here's 21. And 63, oh, I'm going to have to make my 21 a lot smaller. Sorry about that. To make my 63 actually fit as well on the page. Okay, so here's my 21. And in comparison, maybe here's my 63. Okay, so it looks like my 21 is a lot smaller than my 63. And I'm trying to think of how I could break these both down with a number that would divide evenly into 21 and divide evenly into 63. Okay, so here I'm just doing a little drawing while you're thinking about that. Let's try 7. So if we divide this into groups of 7, 7, 7, 7, and divide this into groups of 7, divide out our 7s. My spacing's not perfect right here. It looks like there are 3 7s that come out of 21, and it looks like there are 9 7s that come out of 63. So we've reduced our fraction. So it looks like that fraction would be equivalent. Is that the smallest we can make it, though? Can you think of another number, right, that might divide evenly into 3 and also divide evenly into 9? So on your paper right over here, they're showing something like this. 3 divided by 3 on the top, 9 divided by 3 on the bottom is going to leave us with 1/3. And that is also equivalent to your 21/63. Okay, so it can kind of go both ways. Here's one it looks like you could divide this one probably by 5 in both the top and the bottom and get an equivalent fraction there. So that should help with these two lessons. And then you get to my favorite part of proportions, which is actually using them for cool stuff like conversions and finding missing values and things like that. Okay, so we're not going to make our video too much longer right now. We're going to try one of these. We're going to give you a shot at working with some of these unknown boxes right here. And then we'll call it a day, see how it goes, and see if we need to launch into proportions part 2 after that. Okay, let's switch up colors here just for the fun of it. So one thing to remember when you're using proportions for comparing a value like 1 foot is the same as 12 inches, is that if you multiply your 1 foot times any number, you're going to be doing that same thing. You're going to be multiplying your 12 inches by that same number. So I think that's what they're trying to kind of show you right here. That if you took 1 foot and multiplied it, I'm going to use the dot for multiplication, multiplied it by 3, so times 3 to get 3 feet. Then you would also multiply your 12 times 3 and get 36 inches. Okay, so it's important to know this part first, I think, before you launch into conversions. So for example, you might need to know a conversion like 1 meter equals 100 centimeters, right? So if you were going to try and figure out, how many centimeters would be in 5 meters, then the multiplier here would be 5 times 5, and the multiplier here would be 5 times 5. So 5 meters would be equal to 500 centimeters. And I think I'm going off my screen, so sorry about that. Oh, fail. Okay, so centimeters is on the side there that you can't see. And last but not least, these are crazy. The example I just showed you will help you with these problems, and these are great. I love these little problems right here. You can do them with some mental math. You can also do them with some algebra by assigning variables. And I don't think that's where I'll go today with this, but I'd love to talk to you guys next time about how you might be able to use variables with this particular piece. So this is pretty cool. What they have going here is they have this little piece right here, this 12. You see how that 12 matches up with those two boxes? So what you have is you have this mystery box, right? And these mystery boxes are even Steven right here. So the mystery box is going to be made up of 12 units altogether, which means that this mystery box, and this is what they're showing you in this example right here, is that the mystery box needs to be divided into 2 equal parts, which means each mystery box is 6, right? So when we work with algebra, we'll assign that mystery box a variable and use it to solve equations. So we'll save that for later. But basically what they have here is, then you know, right, that the top line A, because it is made up of 5 boxes, 1, 2, 3, 4, 5, each having a value of 6, that 5 times 6 is going to be 30. Cool. And the B values, because each of your boxes is made up of 6, and there are 3 of them, plus the 12 that you had on the back side here, we got 6, 6. So you have 18 plus 12, which is also 30. And the important thing to see here is, I'm going to change colors for this just because it's fun, and it's also important for you to see that these lines, these boxes, the length of these boxes from here to here, and the length of the box plus 12 from here to here were equal in value. So that's why your 30 is equal to your 30. So it's kind of a cool little example, and you can try it. It's a little bit different on this one, because rather than going side to side this way, you're kind of gathering together what you know about the boxes going up and down. So in this case, all 5 boxes, 1, 2, 3, 4, 5, are going to be equal to 35. So that's why they have this example right here for you. It's kind of a little bit different, but it still works out. So you know your 35, basically, and I'm going to show you some algebra here, is equal to 5 times whatever is in every box, right? That's your question marks. Sometimes in algebra, we'll give that a variable like a letter, which is coming up soon. So you think to yourself, 5 times what is 35? And then you know all of your boxes are equal to 7, right? So here's how it looks algebraically, dividing both sides by 5. And we get 7 is equal to your mystery box, or X in this case. So yeah, I think that should get you through a couple of problems, hopefully, and then we will address any other questions you might have or further lessons on proportions as they come around. Proportions are great because they can be used for so many things, for finding missing values, for conversions. We'll use proportions to solve algebraic equations. You'll be using proportions for solving trigonometry later on. So my message to you is get excited about math and get excited about proportions. All right, take care.